Okay, so let's see what's going to go on here with this topic. Okay, so this is probably a little bit of a fallback to a time when you were younger and you've probably seen the equations of lines. I think most of you may recall the format called y equals mx plus b. That's actually not the only one. In fact, it's not even the most common one. It's not a bad one for young people to learn about first because some of the visual information that we try and decode from an equation is actually sitting right there. I'm sure most of you remember something about m being the slope of the line and b representing something else that's visual, the y-intercept. But despite that advantage, it actually is not used most often because it limits us. There's only certain things that we can do with that. Before I go on, I'm going to be referring to different aspects of straight lines over today's lesson video, so I want to go over them just one more time. When we take a look at the steepness of any line, it's known by one of two words, either gradient or slope. Slope for our American and Canadian friends, and gradient for pretty much everyone else. And because you are internationally minded world IB learners, we have to be aware of both of them, and the textbook will freely revert back and forth, as will your examiners when the exam time comes. So just get comfortable with that slope is a word that we probably used a lot when we were younger, but gradient is a word that we have to adapt to grow to accept as well. There are such things as intercepts. A straight line can cross the y-axis at its so-called y-intercept and the x-axis at its x-intercept. Please bear in mind that whatever the value of that coordinate is, that the opposing one is 0, meaning if you're at the x-intercept, you're at the y value there is equal to 0. And if you're at the the y-intercept, then you're at the x value would be 0. If you happen to have a second line and it's not parallel to the first one, in this case the red one, there's likely to be a point of intersection. So we have to consider that. And these are the formulas from our formula kit. I've copied and pasted them all there. You'll probably recognize the second one, y equals mx plus c. That's the way the British call it. You might call it mx plus b. It doesn't make any difference what letter comes at the end, as long as there's y equals mx plus some number. And there's other formats too, and we'll get into each of them in due time. Okay, now the steepness of the line. Please bear in mind that there are a lot of applications that don't relate directly to the Cartesian plane, and they're just talking about how steep something is. And so we won't be viewing that idea through the eyes of what its coordinates are. We'll just be talking about rise and run, how much a hill or some sort of incline, jumps forward compared to how much it either climbs up or drops down. So gradient will have, or slope gradient will have a dual approach for us. Sometimes on the Cartesian plane, in which case we do tend to focus on coordinates, and sometimes not, in which cases we don't. Okay, so let's get going here. The gradient of a line or slope of a line is the measure of the steepness. If you are on the Cartesian plane, like we are on this diagram here to the right, you'll see those familiar subscript systems where we're going to refer to a number by its coordinates here, and we'll say it's the x and y value of the second point and the x and y value of the first point. It's not necessary technically to have x1, y1 on the left and x2, y2 on the right. As long as those subscripts match up with each other, meaning x1 and y1 go together and x2 and y2 go together, it really makes no difference as where you put them. The formula here, it doesn't look that much different from other things that we've seen already in the midpoint formula and the distance formula. It's a formula which will compute the gradient based on our knowledge of the coordinates of the endpoints or any 2 points on the line, and we'll take advantage of similar type things. So here we go. Here's a very simple one. Determine the gradient or slope of the line that joins A 4,1 to B 8,3. Well, I'm going to make a little chart here. I'm going to segregate what are the x values and what are the y values, and I put them in order so that when I can subtract them easily right there. And I've got the difference between the x values is 4. And the difference in the y values is 2. And now I just got to put that information together in that formula and say that y2 minus y1, which was previously computed to be 2, divided by x2 minus x1, which is computed to be 4. And this whole answer, therefore, would be a half, or just call it 0.5. And here's a diagram of what that would look like. Here's 4, 1. There's 8, 3. And you'll notice that the gradient is upward facing, so upward pointing, and that means it's a positive gradient and not terribly steep, so the number 0.5 isn't that great, isn't that big. If a line as we go from left to right tails downward, then we say it's got a negative gradient, negative number. And if it goes upward, it's got a positive gradient. A zero gradient, of course, is when it's neither pointing up nor pointing down, in which case it's pointing just across horizontally, and we say the gradient is 0. Now we also have one we can't define with a number, and it's called the undefined gradient, and that's a vertical line, and that's because it climbs infinitely as you step across. In fact, you can't even measure how high if it's vertical. The slightest step over from left to right would cause it to grow infinitely, and we don't have a number for that. So that's why vertical lines are said to have a non-defined or undefined gradient. And of course, we're just talking about steepness and direction. Direction, of course, meaning pointing up or pointing down. Let's determine the gradients of these lines here. Well, you'll notice that they've given us the lines, but they've not indicated explicitly or directly any points on the line. We're going to have to go find those for ourselves, because working with our gradient formula depends upon us knowing the points on the line. So let's take a look at this first one here. I just grabbed any two random points that I could, and I could tell because you can see that they fit directly on these block or these square line numbers here. It's not like between a couple of different points. So I can accurately describe what the ordered pairs are there. So I'm going to go ahead and put that information into a little table for myself. That point over there is 2. Top one is 2, 5. Second one is 8, 2. Remember, X precedes Y. Stick them in my little formula. You don't have to do it exactly like this, so long as you can accurately find out the difference between those values and the difference in the Y values, which I've done. And then it's the difference in Y's divided by the difference in X's, and that gradient is negative 1/2. If you recall a previous example, you can see that this line is also pointing downward, not terribly steeply, and so that's why it's negative, but not a very huge number. If I would do it again with a second case there, I can see that, and again, you can put these in any order you want. The difference between the X values is negative 5. Make sure you get them in order there. Once you establish which one's which, you got to subtract. You can't say the difference is 5. It has to be 0 minus 5 once you put them in here, and that's negative 2. And when you divide them, negative 2 divided by negative 5 becomes a positive. And of course, this line is pointing upward, but not very steeply, so we call it 0.